Welcome. This is a C4 Edexcel past paper. Now this is question 2 of the January 2012 paper. Now, as we said, so in this question, what we're using is testing. I mean, it looks like it's just an integration question from the start because we've got this integrate x sine 3x. Now, what you might be tempted to do, obviously, it's part A. Is go, okay, well, the integral, I know the integral of sine 3x, which is the opposite of differentiating it, so you'd change it to a cos 3x, but it'd be a cos 3x over 3, and because it's integrating, we change the sign, so it's negative cos 3x over 3. And that's times by x, so you take that out as a common factor, maybe, and say, okay, well, then, therefore, the integral of x sine 3x, this is incorrect, by the way, is x cos 3x over 3. Oh, sorry, negative x cos 3x over 3, which is completely wrong. Because what this is saying is x times sine 3x. So what we've got is a product. Now, what might spring to mind is the product rule. However, that's to do with differentiation. So this is also known as sort of the reverse of the product rule, so to speak. So, because we've got two products here, we've got u, and so basically I'm going to write out the equation and we'll pair it up. So this is, okay, so this is the idea of what we've got to differentiate, integrate, sorry, get the right term. So what we've got is u and dv dx, and when we integrate u times dv dx, now x being u and dv dx being sine 3x, but don't worry, I'm gonna write what each bit is down in a minute. That is equal to u times v, take the integral of v times du by dx, or the differential of the first term. Now, one thing I will stress at this stage, this isn't particularly relevant to this question, but when you're choosing what u is or what dv dx is, u, in this generally, this is generally the general rule, that u is always the first term. So it's always presented in the way that we write the equation. So therefore, if we look at this, so we're focusing on the first bit of this equation, the integral of u times dv dx. Therefore, because this is the integral of x times sine 3x, we say u is x and dv dx is sine 3x. That's not a problem. That's perfectly correct, and it is so for this question. However, if the question didn't say that, and it said something like the integral of x times the ln of 3x plus 2, say, even though it's in the same form as this integral of x sine 3x with respect to x, so both with respect to x, we wouldn't call, it's not presented in the same way. That's because the differential, it's really hard, basically, it's really hard to integrate the ln of x. It can't really be done at our level. So we always assume that u is the ln of x, because nothing really differentiates to ln of x that we're concerned with anyway. So basically what we've got here is whenever we see an ln of x and we've got some kind of product like this, so maybe it's not x, maybe it's say 3x squared times the ln of x, ln of 3x plus 2, and we have to integrate that, u will always be the ln of x. It will never be the first term. But generally, when we're not considering this, so we're just considering what the question in this case is actually asking, it's the whole point of this video, u will always be the first term. Now for this question, question 2, this is the only rule we're concerned with because they're both presented, part A and B. B we'll go into on a second, but they both use this rule, which is the reverse of the product rule, obviously. However, there is another rule that we use, which is, as I said, you don't really need to worry about this, but I'm going to rub it off, so I'll draw it in a different colour pen actually. So, as I said, we're not interested in this rule, but this is just the other rule to recap the integration. So that's integration by parts because it's broken up. This one is integration by substitution, which I personally think is a bit more challenging because it's not as clear cut as that. So the the integral of f of x is the integral of f of x times dx by du with respect to u. Let me make sure I've doubly got that right. As I said, I could have the dx and the du upside down. So I'll just double check, but I think that's right. One sec. I mean, you can obviously check for yourself, but it's in that kind of format. So that's called integration by substitution. But I'm just going to double check. So A level C4 Edexcel. Sorry, I'm just double checking. So as I said, that's integration by substitution, where generally in these kind of questions you're given x equals, so u equals 3x plus 2, for example. But as I said, that's not really for this question. I'm just double checking because I don't want to say that's the rule and then it end up not being the rule. I've told you completely something incorrect. So I want to avoid that. Okay. Just yeah. Oh, it doesn't tell you. It doesn't tell you that rule actually. It tells you that one. So that's on the formula sheet, by the way. So you don't need to worry about that one. But just check actually. I should have just gone straight to my classmate, but really. But you know, never mind. Sorry, I know this isn't brilliant, but you know, never mind. Oh great! Never mind. Right. You know what? Stack it. I think it's dx by du, but that could be upside down. If it is, sorry, if I've got that wrong, if you're not sure on that one, and I've made you unsure, I have done a proper video on that, which I don't want to spend half an hour trying to find where I've done one of these questions, so I could double check it's times dx by du and not du by dx, which I actually think it is du by dx. Something tells me it's f of x times du by dx time with respect to x. Yeah, that's right. Anyway, so sorry about that. That was just me getting my head a bit messed up. As I said, there's a proper video on that. So you know, if you're unsure of this, it's the integral of f of x equals the integral of f of x times du by dx, not dx by du as I thought. I think. So anyway, if I have confusion on that, please do check out the video because I make more sense in that video than I am doing now. So anyway, as I said, that was just the other rule. I probably shouldn't have brought that up actually. I should have just mentioned it and gone, oh yeah, there's another rule. But you know, awkward, so we'll carry on with this one. So, what I generally do before I start this, because this is in the form of this, now what we could do is go straight to going, okay, well that equals then, if u is x, then we'll just write x, and we'll think of what because we've got dv dx, and to get from dv dx to v, we have to integrate it, so we could think in our heads, on our feet, okay, rule, well, the integral of sine 3x is negative cos 3x over 3, and write it in as such. But what I prefer to do, as I said, you know, if that works for you, you're more than welcome to. Obviously, I'm not going to stop doing the exam. But what I personally like to do is go, okay, well, look, I did. This is why doing physics is good with this. Think, right, what have we got given? What do we need to find out? I write it all down, and then we can see how we're going to get from what we know to what we want to find out. So what do we currently know? Well, we currently know u. So I'm going to write what u is. U is equal to x. And we know what dv dx is. So over here, I'm going to write dv dx equals sine 3x. Okay. What do we need to find out? Well, obviously we need to find out what this equals, but I mean the individual terms. So we know what u is, we know what dv dx is. The other terms in this equation we need to find out is v. So what is v? Now as we said, the integral of sine 3x is negative cos 3x over 3. As I said, there's a proper rule, there's a proper video on, correct video, on that, so if you don't get that, do check out the video, but I'm assuming that's okay. What we also need to know is du dx. Now instead of du dx or dv dx, I could do v dashed or u dashed, but seeing as this is the equation I'm going from, I'm just going to use this idea. So du dx is x, you differentiate x, which is obviously just 1, okay? Okay, so that's the bits of the information that we need to know. We can just go ahead and use this formula now. So what I might do is again rewrite out what you get given. So the integral of x sine 3x with respect to x. And if you can, write it underneath like I've done. So set your page out this. So you've got the formula and then underneath the your workings out. Okay, so you can always refer to the formula above. So you go, okay, I've got that bit, and then you need to know, you can always look up and what you're filling in. So if that doesn't make any sense, don't worry, I'm probably talking too much anyway. So that is equal to u, so we know u is x, times dv dx, sorry, times u, times v, let's take u times v, so v we said is negative cos 3x over 3. Now you could easily write negative a third cos 3x, but I prefer to do it awkwardly. So let's take the integral. Now it's not the integral of v times du dx, it's the integral of the whole thing. So it's the v times du dx, and then integrate that answer. So I'm just going to write it out before I do any calculations. So we know what v is because it's over here, so it's negative cos 3x over 3, or as I said, negative a third cos 3x, and that's times du dx, which we said is 1. So you would get away with just if you forgot the du dx on that one. And then again, I'm going to write out the integral of sine 3x with respect to x, just so I can keep it going. So I'm not having to look left and right, I can just look down. So x times the cos 3x is just, you can put it as negative x cos 3x over 3. So you don't have to really do anything fancy with that. Next, take the integral of negative cos 3x over 3 times 1. Now I'm just going to go straight. I'm going to skip out a step because I'm quite conscious that you don't want to waste your whole life on this. Some of it is probably okay, but I wouldn't recommend all of it. So I'm just going to go straight to integrating negative cos 3x. So when we integrate cos of 3x or whatever, the sign is the opposite to differentiate it. So when we differentiate cos, we have a change of sign. So therefore when we integrate it, we don't have a change of sign. So the sign stays the same. However, we still divide it by 3. So cos, so that becomes negative sine 3x, divide by 3, and then because it's already divided by 3, you have to divide by 3 again. So a third divided by 3 is essentially what we're doing. And that is a ninth. So therefore, this is take away negative sine 3x over 9, or negative ninth sine 3x. Now, because we're taking it away here, so I'm going to sort of rub this out. You can't really do that on your board or whatever. Mine's obviously plus, so you write plus there. Now, what you could do at this stage if you wanted to, I mean, as I said, it's totally up to you what you choose to do for this. But you could either, so obviously, sorry, you need this plus c on the end, because when you integrate you get constant. Now that isn't really good. If we were using limits that wouldn't be relevant, but because we're not using limits, you need to keep it there. I mean, I would include it anyway in any integration you do, but you probably could get away with it if you're doing limits, because they're not really bothered about that stage. They're bothered about the exact answer or whatnot. So anyway, there's just waffling on, so you can spend, half said you've spent a bit more time revising than you probably have. So anyway, that's the equation. As I said, you can rewrite it so it says equals sine 3x over 9, take x cos 3x plus c. Now I would prefer to write it in that way, but because I don't want to confuse everyone, I've kept it. So basically, we've got this equation and I've just kept this side the same because we're obviously not changing that, and then just simplified the right hand side, but keep always looking up to this equation and say, okay, what do I do next? So not losing track of where we are. So one second, I'm just going to double check that. So I'll triple actually, because I double checked it before. Okay. Yep, so that's what you do. Right, so 2b, or part b. 2b says, using your answer to part A, find the integral of x squared cos 3x with respect to x. Now, this could have easily have said, hence find the answer to the integral of x squared cos 3x with respect to x. They both mean exactly the same thing. So hence means using your previous answer, or in some form using how you worked it out. Now, I don't know about you, but I can see, apart from the method we used, which isn't what this means by using your answer to part A, because your answer is obviously that part there. Because it says using your answer, we have to use this at some stage. But obviously that means, I mean, just by comparison, I'm going to use the same method. But I don't know about you, but I can see no relation from initially starting off that we could say, okay, the integral of x squared cos 3x is negative x cos 3x over 3 plus sine 3x over 9 plus c, because that's the integral for this question. And there's no way you can go, okay, well that's squared then, and that's cos, so you divide it by tan or something like that. So you wouldn't faff around with anything like that, okay? You do the same method that you did for this equation, but we've got to include this answer somewhere in our work, it's going to help us out essentially, because generally, like physics, maths requires you to, if you've got a question, if you've got part A and B, part A will generally be helping you with part B. I mean, not always, but generally will be, like in this question. So what I'm going to do is do exactly the same method that I did for part A for part B. So this is saying, I'm going to go through it in the exact same way, so you get to listen to my voice for that little bit longer for those of you that love listening to it. So what we've got is the integral of x squared times cos 3x. Okay, so we're going to apply the same sort of method as I said. So therefore, if we use this, now I could rewrite this equation down here, and I would advise that if you're doing this exam. As I said, it is in a formula book, so you don't need to worry about learning it. For the lazy people in the video. So u is equal to x squared. So what do we know? So we know u is equal to x squared. We know dv dx, which is cos 3x. So dv dx is equal to cos 3x. Okay, so what else do we need to know in this equation that we don't already have? Well, it's going to be the same things we had to find out in part A. So we had to find out what v was. So therefore v, as we said, dv dx, v is the integral of the differential of v, or v is the integral of dv dx. Now the integral of dv dx is the integral of cos 3x. Now we said to integrate cos 3x, it's the opposite of differentiating cos 3x. So differentiating cos 3x, what we did is we changed the sign and times by the differential of x. However, because we're integrating it, the sign isn't going to change because it can't. And instead of times it by 3, we're going to divide by 3. So it's the same method as I said to go up as we did before. So the sign isn't going to change, so it just says sine 3x and we divide it by 3. Now, as we did before, you could have put a third of sine 3x. As I did over here before, in the answers it does say this is equal to negative a third x cos 3x and plus a ninth sine 3x plus c. But they both mean the same thing, you'd get the marks either way. Okay, so we know what v is now. We want to know what du by dx is, because that's the only other thing to find out. Now, the derivative of x squared is simply 2x, so just leave it as 2x. And then follow the same principle we did before. So, therefore, the integral if I rewrite out the equation, so the integral sign, get out of the way. So the integral of x squared cos 3x with respect to x is equal to uv, u being x squared, v being sine 3x over 3, or a third sine 3x. I'm going to keep it as a same thing, so sine 3x over 3. And you take that away, you do the integral of v, which is sine 3x over 3, so sine 3x over 3 times du dx, which is 2x. Okay, so simple fact, nothing's jumping out straight away at me here. Okay. So what we're going to do now is, as I said, do what we did before, but obviously integrating something in here is going to be like what we did before. So our answer, always keep in mind, okay, how are we going to, so we're going to have to integrate something like this. So therefore, x squared cos 3x with respect to x is equal to, so we expand the first term, so that becomes x squared sine 3x over 3. Let's take away from the integral of, as I said, I'm going to break this one up a little bit more than I did for the previous one, because there's a little extra bit we have to be able to understand. So let's take away from the integral of, so I'm just going to expand this, so that just becomes 2/3 of x times sine 3x. So that is essentially saying 2x sine 3x over 3. Obviously, it's with respect to x. Okay, so then I'd rewrite out this again. So the integral of x squared cos 3x with respect to x is equal to x squared sine 3x over 3. Take away. Now the integral of 2/3 sine 3x. Now we don't know, because this is now looks something like x sine 3x. However, it's times by 2/3. So what we could either do now is, because we know what the integral of x sine 3x is, we could either times it by 2/3 or take out 2/3 as a common factor and then put it back in. So that's what I'm going to do. Okay. So where we've got the integral of 2/3 times x sine 3x, I'm just going to rewrite this top bit here as 2/3 times the integral of x sine 3x. Now the reason we had this question was to help us with this, and this is exactly where we're going to put the answer. Now working out what x sine 3x is, if you were just given this question, you would have to do this question as well to be able to work out just what the integral of x sine 3x is. And it'd take a very skillful mathematician to be able to not get confused by all the u's and v's that you were using. I mean, as I said, it is possible if you didn't spot this, but if you didn't spot that you had to use your answer for this question for part A in this part here and to move out the 2/3. As I said, you still could have done it, but it would have taken you a hell of a lot longer. And in the C4 exam, time is one thing you definitely don't have spare of. So anyway, what we're going to do is we're going to do 2/3 times this answer. So we know what the integral of sine x sine 3x is, so 2/3 times, so I'm just going to write this in brackets, so x cos 3x over 3 plus, so that's negative x cos 3x by the way, plus sine 3x over 3, or a ninth of sine 3x. You don't need to write the plus c because we're going to write plus c as one big thing at the end, really. So you don't need to put 2/3 of c because that wouldn't make any sense. I mean, it'd be 2/3 of that c, but this is a different question, so you don't have to relate them specifically. So that's why, you know, I could put this in brackets really. You don't really need to include that. Okay, so if we expand this out, so we write the integral of x squared cos 3x again with respect to x. So then we're still going to get this x squared sine 3x over 3 business in this off the board. So if we expand this out, so just move it out of the way so you can see where we're going from here. We're going to get, because this is a negative 2/3 times negative x cos 3x over 3, we're going to get positive 2/9, or 2x cos 3x over 9, but I'm just going to write 2/9 of x, 2/9 of x cos 3x over 3 because I'm slightly running out of space, plus, no, well it's not plus, it's minus because it's negative 2/3 times positive sine 3x over 9, so that's going to be negative 2 sine 3x over 3 times n, which is 27. So it's going to be negative 2 over 27 times sine 3x. So I'm just going to change this first term actually to a third of x squared sine 3x. So that's your answer. Okay. So as I said, hopefully that came across to you in that question. It's a nice 6 marks really. As I said, you could have done this question by working out what x sine 3x is, but you would have just been copying yourself from there, which you might have spotted halfway through answering this question. Okay, so thanks for watching. As I said, hopefully it's been some kind of help, and it looks quite scary, I'll admit that. Doesn't look particularly nice, but hopefully I've explained it to make it seem quite simple, because it is definitely, if you get this formula, it's the most simple question on the paper, bar the exception of the partial fractions one, I think. So anyway, thanks for watching. Hopefully it's been some kind of help, and we'll see you in question 3.